Okay, folks, so now the last bit is to do an unsupervised classification. So what you just did was a supervised classification. So you told QGIS what the different spectral signatures were. So like this is grass, this is residential, et cetera, et cetera. An unsupervised classification is you just say, hey, this is my image. I want you to come up with so many classes. You get so many iterations, so you get to like go over it so many times to try to figure out what the best combination is, and then let me see what you come up with. So if you go to here's our band set screen, if you remember that from before. If you go to the band processing and you go to clustering, here you have, this is our unsupervised classification. So we can use one or two different algorithms, k-means and ISO data. I'm just going to use k-means. And we're using input band set 1. Okay. The distance threshold, that tells you, okay, how far away the spectral signature has to be in order for it to be called a different class. So it's like a minimum threshold. Number of classes. So, there's a trade-off here. The more classes let's just do 10, let's do 10 classes, say. So the more classes you do, the longer it's going to take to actually compute it. So there's this balance between computation time and the number of classes. And you might be splitting hairs, right? So too many classes isn't necessarily good for you either. Maximum number of iterations, let's just put 10. Again, there's this balance between computational time and how much of a chance you give the algorithm to go through and make sure it's done the best job it can. So again, ISO data max standard deviation. So if you're using the, so this tells you how far apart spectrally they can be, and this tells you don't want all these teeny tiny little classes. So this tells you the size, the number of pixels you need in order for it to be a legitimate class. And this just says find a place for it to start, right? So it's saying go ahead and use our band values to figure out where to start, because it's going to wander through all of the possibilities. Okay, so this is going to take a little bit of time. So I'll say run. And we'll call this unsupervised classification, k-means. Just store it in the same folder as the supervised classification. It's going to take a little bit of time. So we'll check over. So you can see that it's running right now. So it's a lot for it to run over to try to process. So right now it's iterating over all the different pixels. And by the way, if you do find, the unsupervised classification actually made these two classes, but I want to condense them down into one, et cetera, et cetera. You can change it, whether it's the supervised or the unsupervised classification. You can combine classes. You can split classes. You can split classes out. So that's not a problem. And that's covered in post-processing, which I will post a video of someone else doing it. Again, I think that's just kind of beyond our purview here. So here are our results. It's kind of interesting. So it looks like the water I'm going to go ahead and I think a lot of these colors are too close to each other. So this is water. So we'll call it blue. Okay. I'm just gonna change these colors a little bit to get them to stand out just a little more. Okay, so we do have 10 classes. Okay, all right, that helped. That brought some of the data out to the forefront. So looks like, so when we compare this to our supervised classification, looks like we did pretty good with the water bodies. Residential, this might actually be too many classes. So you may want to try to run it again and get, try 8 or 7 classes and see if you get a better result there. This is pretty interesting. So what was basically a set of buildings is now, you've got a class for different brightnesses of roofs, which is pretty much overkill there. But so it's a whole heck of a lot less work to do an unsupervised classification. So anyway, you folks will be able to do one for your area, compare, see what you come up with.